This is part 2 for section 10.1. Let's see what we're doing now. We're going to do 2 circles here. Actually, let's do this one with a radius already drawn on it. And let's do another one. Okay, now watch. Remember how we had congruent triangles? We can have congruent circles as well. Let's just call this triangle, or I said triangle. Let's call it circle A and circle B. And I just copied and pasted these, so what do you think is true about the radius on both of them? They're the same, okay? So now I just gave you a hint. We talked about this in triangles, and if they are exactly the same, then what can we say about them? They're congruent to each other, that's right. So we can say that I keep saying triangles now. 2 circles are congruent to each other if they have the same radius. Good, okay? So if they have the same radius, then they are congruent triangles. Now they're... Did I say triangles again? Yeah. Oh my word. Why am I saying that so much? Anyway, circles, congruent circles. I guess I'm so used to saying congruent triangles, it just kind of comes off the mouth. What's that? Well, if they have the same radius, they'll have the same diameter. So it doesn't make any... I mean, yes, that would be true, but you don't have to say it. All right? So we say that these circles, I almost said it, triangles, these circles are congruent to each other if they have the same radius. You follow me? All right, I think that's pretty easy. That's all there is for that little part. Let's go to something else. Let's do this. This is kind of cool. Let's go to the one without the radius. All right, let's make this one a little bit bigger. And let's put this one right here. Now watch. You ever see a bullseye? There are a whole bunch of circles inside, but what do they have in common? What is the bullseye to that target thing? The center. Okay, remember, we're not saying middle anymore. We're saying center, okay? So that point that you want to hit is the center of the circle. Now watch, if I had 2 different sized circles, and they both shared, listen to me, they both shared the same exact center, then I could put it right on top of it like that. Bang. There, that's a little bit better. Right there. Okay, yeah, bullseye right there. That would be the bullseye. We have a circle inside another circle, but it's not just a circle inside another circle. It's not like this, right? They share the same center, all right? So if they share the same center, then they have this name. They're not called similar. It's a good suggestion that they might be called similar, but they're not. They're called concentric circles. You ever hear that word before? No. Concentric. Did you already know that, or did you look in the book? Okay, that's all right. That's why we're doing this. See, I don't know why sometimes I use capital and sometimes... It seems like when I write on the board I go more capital letters, and I write on this I have a tendency to go lowercase. Anyway, it doesn't make any difference. They're called concentric circles. That's all that is. All right. Do they both have the same radius? No. Okay. Because if one is actually let's just go like this. Okay. There's the radius for both of them. Obviously, the radius is different, but what is in common, though, between all these? If you wanted to do this, you could say that that's A, B, and that's C. They obviously don't have the same radius, okay, but they do have what? The same center. They have the same center, okay? Both of these circles could be considered circle A, couldn't they? All right, and how could you tell the difference between them? I really don't know. I don't know what they would do if you were going to talk about the 2 circles, because they're both. Yeah, I guess you could say AB and AC, but we name a circle. I don't know. Maybe somebody is on there watching the YouTube thing and say, "You dummy, you should know this," and they probably have some reason, and they should email. Then they should email me and let me know, because I don't know what you would do there. All right, we're being silly. Let's continue. Oops, I'll get rid of that mess. I like keeping that section number on there. Okay, I think we have one more thing to do. This is something that you've done before. If you're going to find the circumference of the circle. So let's draw us a circle just so we can visualize what's going on. Now, the circumference is the distance around the circle. All right, so if I started here, if I started here and went all the way, now this is going to be kind of sloppy, but if I went all, oh my, let's pretend, I had too much Red Bull today.
Baseball, you're now dismissed to the Pusey Center stage, where you will meet Coach Pusey.
Was that varsity?
That was varsity.
Okay. Any varsity in here?
Nope.
Good. Okay, so here, come on. We got to pay attention, ladies, please. All right. We got to finish this up. So the distance around the circle, I know it's a little ugly, a little sloppy, but if I walked all the way around this circle right here, then I would find the what of it? Somebody already said it. Circumference. There I go to my all caps again. Circumference. All right, that's the circumference of the circle, which basically means the distance around. The distance around could also mean the perimeter. You could also refer to it as the perimeter, but on circles, nobody does. On a circle, they don't say the perimeter of the circle. They usually say, almost all the time, say circumference of a circle. Okay. Now, we have a formula for circumference of a circle. Do you remember what that is? Okay, 2 pi r. And there's another way you could write it, too. A lot of people don't learn it this way, but you could. Because look, twice the radius is the same thing as the diameter. So you could also say pi times the diameter. Either one of those is acceptable. It's no big deal. I think it just depends on what they give you in the problem. Okay, if they give you the radius, then use that. Or you could just double the radius in your head, couldn't you? And then multiply it by pi. It really doesn't make any difference. So there you go. So that's circumference of a circle. You've learned that before. It's not that big of a deal. It is a formula you should have memorized, though. In the other class, I asked, okay, what's the formula for circumference of a circle? Guess what they said? What would be a common mistake? I'm not faulting them for saying this, but this is a common mistake. Pi r squared. They said pi r squared. That's not circumference. What is it?
Area.
Area. That's the area of a circle. Do you remember that? Because area is always something squared, isn't it? Inches squared, feet squared. So pi r squared is going to go with area. Look at the units here. The units here, for instance, what if I'm going to be real sloppy here because of time. But let's say that was 5 inches, and you wanted to find the circumference of this. Okay, so circumference equals, you could just go pi d, couldn't you? Okay, pi times what? 10. All right, that's a good way to do it. Now, if you wanted to, you could use a calculator. And if you have a calculator like this, let me just show you how we do this real quick. It's pi. So it's second function, that thing right there. That's how you get pi. Actually, you know what I should do? Let's go 10 pi. I think you could still put pi 10, but let's go 10 pi right there. And you should know what it is, because 3.14 times 10 is what? 31.4, so you click it, and there it is. Okay, so if we just take it 1 decimal place to the tenths, we just say it's 31.4 inches, right? Because this is 10 inches. 5 inches is the radius. The diameter would be 10 inches. 10 inches times pi is 31.4 inches. Not inches squared, right? Just inches. Inches is a distance around. So it's not area. Everybody got that? All right. We'll talk about area in another chapter. Not in this chapter, but in another chapter they will talk about area. All right. Let me just take a quick look to see if there's anything else we left off. And I don't think... inscribed and circumscribed. I forgot to do that, but I didn't do that in the other class. I don't think that's really important at this point right now. Once we need it, we'll talk about it. It will take not that long. I'll tell you what, let's just do that. Let's just, watch, let's talk about inscribed. This won't take long. There's really no like math involved in it, like numbers and stuff. It's just vocab. And let's go to this. Watch this. If I took, let's take a quadrilateral, all right, and I made sure, you guys listening? Up here, pay attention, look up here. If I had a quadrilateral and every single, and I'm trying to draw it so it doesn't look like a square because it doesn't have to be a square or a rectangle, but if I had a quadrilateral and every vertex of that quadrilateral lies where? On the circle. Do you see it? Every vertex, that's supposed to be on the circle, but every vertex is right on the circle. We call that, we say that the quadrilateral is inscribed. You like that word? It's inscribed in the circle. Okay? So it's inscribed in the circle. One more. We could also say that the circle... Let me finish this word.
Gossett, Faith Johnson, Amber Buchanan, Jonathan
I think they
Lumpkin,
say about
Sean Morrison,
the polygon
Malik
or the
Wright.
quadrilateral.
Please come to the upper school office, and Kate Netzer. Thank
Okay?
you.
So we just say it's inscribed. This is inscribed in the circle, or we could say the circle is circumscribed about the quadrilateral. Make sense? Just vocab, no big deal. You don't have to worry about any math on that. Okay? All right, that's done. Everybody say bye on YouTube. Everybody say bye.
Bye, YouTube.